Welcome to the Combined Cycle Overview presentation. A combined cycle power plant combines a simple cycle gas turbine configuration with a steam turbine to provide additional power output from the plant while increasing the efficiency of the plant. To merge these technologies, a heat recovery steam generator, or HRSG, is utilized on the exhaust of the gas turbine to recover the useful energy in the hot exhaust path in order to generate steam for operating the steam turbine. The gas turbine itself contains three primary sections: the compressor section, the combustor section, and the turbine section. Inlet air is drawn into and through the compressor section, where it is compressed and delivered to the combustors. In the combustors, the air is mixed with a fuel source, generally natural gas or fuel oil, and then ignited. The hot exhaust gas from the combustors is then directed to the turbine section, where much of the energy is converted to rotate the turbine and all attached equipment, including the gas turbine generator, where the rotational mechanical energy is converted to electricity. The exhaust of the gas turbine section still contains a significant amount of energy. Much of this energy is used to generate steam in the HRSG, located in the exhaust path of the gas turbine. Various HRSG designs are utilized by the power industry. A typical three-pressure HRSG, low pressure, intermediate pressure, and high pressure, is shown here for illustrative purposes. Each pressure level of a HRSG produces steam at specific temperatures and pressures determined by the design and application it is used in. Typically, each pressure level will preheat incoming water in preheaters, also called economizers. Water then flows to a pressure drum, where it is driven down a pipe and then back up through a riser or boiler section in the HRSG, where approximately 10% of the water is converted to steam. The steam then exits the pressure drum and is delivered to superheaters and then finally exits the HRSG, so its energy can be utilized by the steam turbine, which drives the steam turbine generator to produce electricity. A typical HRSG also includes additional components for emission controls, such as a selective catalyst reduction system, or SCR, and may contain duct burners, which burn additional fuel to provide more heat to maximize steam production, utilizing excess unburned oxygen still present in the gas turbine exhaust stream. The steam produced by the HRSG is sent to a steam turbine. A typical steam turbine will utilize high-pressure steam in a high-pressure section of the turbine. The exhaust from that section of the turbine still contains a significant amount of useful energy. That exhaust steam, called cold reheat steam, joins the intermediate pressure steam produced in the HRSG. The combined steam flow is further heated in the HRSG in sections called reheaters, and then exits the HRSG as hot reheat steam. This hot reheat steam is used to drive the intermediate pressure section of the steam turbine. Exhaust from the intermediate pressure section of the steam turbine is combined with the steam produced in the low pressure section of the HRSG, and then drives the low pressure section of the steam turbine. The exhaust of the low pressure turbine is condensed and stored in the condenser hot well. This condensed steam is then reused in the plant as condensate and feed water to continue the steam cycle. Each turbine and associated generator has necessary support systems to facilitate their operation. Some of these include lube oil systems to provide cooling and lubrication, control oil systems to provide hydraulic operation of control equipment, a turning gear, and other necessary systems depending on the particular design utilized. In conclusion, a combined cycle plant utilizes a gas turbine to produce electricity in the gas turbine generator. The exhaust is then used to generate steam in the heat recovery steam generator. That steam is then converted to electricity in the steam turbine and steam turbine generator. Numerous support systems are necessary to support the operation of the plant, and major plant equipment such as the turbines and generators. Utilizing a combined cycle plant increases both the amount of electricity generated by the plant